Good afternoon and welcome to today's ASA Abloy Academy virtual instructor-led training on calculating occupant loads and egress width. My name is Katie Flower. I will be your instructor for this afternoon. And just to remind you, in case this is your first time attending a virtual instructor-led training, you will get an email from us within 24 hours as a thank you for attending. This can be used as proof of attendance for 1 hour continuing education credit if you need to submit it to somebody for credit. And if you have any questions, there is a Q&A on your Zoom control panel. You can type in your question. I'll be monitoring that throughout, and I will save some time at the end for any questions that you may have. Also, this session is being recorded and will be available on the ASA Abloy Academy website. If you click where you registered for the class, the virtual instructor-led training tab, on the top right-hand corner, there will be a link to previously recorded sessions. And that way you can review as often as you need to or would like to. First thing we'll talk about is the difference between codes versus standards. A standard is a set of criteria by which everything else is measured or compared. For example, in our industry for commercial doors and hardware, NFPA 80 is the standard for fire doors and hardware. It won't tell you where you need a fire door and hardware, but it will tell you if you need a fire door and hardware, this is what it needs to look like, act like, and be like. Other standards we use that you see, ANSI A117.1, the standard for making buildings accessible. And again, these standards are referenced in the code. The code is adopted into law either in whole or in part by your state, your city, or other jurisdiction. And by virtue of the reference in the building code, the standard becomes part of the code and part of the law. The IBC has been adopted by every state in the United States in one version or another. You can always check, this is a great resource, www.iccsafe.org, and then type in the state. It will tell you which IBC the project falls under. There are times when you may use IBC and the life safety code. The Egress Calculator is designed for the IBC, very similar for NFPA 101, but this is specific for the IBC. We'll hit a couple of definitions. The first one is means of egress. In order to select code compliant doors and hardware for a project, you need to understand what constitutes a means of egress. We have the exit access, which is that portion of a means of egress that leads to an exit. The exit is going to be both vertical and horizontal. It includes exterior exit doors, as well as vertical stairs, horizontal exits, exit passageways, for example, and the exit discharge, which is from the termination of an exit to a public way or safety. It's a continuous, unobstructed path of vertical and horizontal egress travel from any occupied portion of a building or structure to a public way or safety. How many exits that we have is based on the occupant load, which can be calculated, and that's what we're here to do today. It's based on the square footage of the area, the space, the room, and the occupancy type. Table 1006.3.1 tells us that from any space or story, the number of exits or exit access, when we have 1 to 500 people, we need a minimum of 2 exit or exit access doors. From 501 to 1,000, we need 3, and more than 1,000, 4. IBC is an exceptional code, and there are exceptions pretty much everywhere. So be aware that there are some conditions that allow for 1 exit or exit access from a space. Table 1006.2.1 will have those exceptions. The egress calculator will default to 2 if it's between 1 and 500 people. And if there's an exception, you need to apply that exception based on the occupancy type, whether the building is sprinklered, the common path of travel, your travel distance to exits, all of those factors in order to determine whether you are granted the exception. Occupancy types, the code is written around ordinary hazard, ordinary risk, and then it's modified to be more restrictive for high-risk occupancies, and it's also modified with exceptions for low-risk occupancies, and they'll be less restrictive in that case. The high-risk occupancies include Group A assembly, which is by definition gathering 50 or more people for the purposes such as civic, social, or religious functions, for recreation, entertainment, food or drink consumption, and awaiting transportation. Some examples include nightclubs, restaurants, large ballrooms, dining rooms, dining areas, bowling alleys, libraries, football stadiums, movie theaters, things like that. And they're high risk because people are unfamiliar with their surroundings. They tend to push and shove, and they all are trying to reach the exit at the same time. There's a lot of people cramped into a small space. There may be tables and chairs in their way. And by the time they realize there's a fire or other emergency, they're going to be pushing and shoving and trying to get to the exit at the same time. Group E, educational, is also considered high risk, and that includes K through 12, including nursery, school, and some daycare. And even though children have fire drills and they go to school and are familiar with their surroundings, they're there every day, school-age children are prone to panic if there is a fire or other emergency. And Group H, high hazard, is not a high occupancy. In fact, it's a non-occupied space. It's going to be some kind of a storage room, but the materials are either highly flammable or prone to explode, and therefore they're considered high hazard and high risk. Ordinary risk occupancies include Group B business, which is professional services and includes colleges and universities. Group M, mercantile, the selling of merchandise, and Group R, residential, which would include hotels, apartment buildings, dormitories, and the like. And our low risk occupancies are Group I, institutional, the ones on the screen, assisted living, hospitals and nursing homes, detention and correctional facilities, adult and child daycare. What these have in common is that the people are not capable of self-preservation without the physical assistance from somebody else. So staff will help these people evacuate or move to an area of refuge within the building as they wait for the next step. And then we have mixed use, where you have more than one occupancy type in the same building. And depending on if the building is separated, where you have your own separate means of egress, if that's the case, you have your own separate exits for the assembly and the business area, then you treat each one independent and individual of each other. But if you have a mixed occupancy and the Group A assembly is mixed together with a Group B business or a residential, you have a hotel that has a large ballroom in it, and they share the same egress components, corridors, stairs, doors, then the hardware that is selected needs to be based on the more restrictive requirements, which would be the Group A assembly occupancy. IBC tells us that the minimum clear width of a door in a means of egress is 32 inches, unless by exception, and the calculator will round up. If it comes up, if you have a low occupant load, and let's say that it came up with a figure of 7 inches, it will round up to 32 inches minimum clear. If you have an I2 hospital or nursing home where you have the movement of beds, then you need to adjust the clear width to 41.5 inches minimum clear. A standard 3-foot door, a standard commercial door that's 1.75 inches thick, hung on butt hinges, continuous hinges, or pivots, the way that you can get the clear opening is subtract 3 inches from your nominal width. So a 36-inch door minus 3 inches with the door open 90 degrees would give me 33 inches of egress width. If you have a 48-inch leaf, subtract 3 inches, you have 45 inches of egress width. Egress doors shall be of the pivoted or side hinge swinging type unless by exception, and there are many exceptions, but we'll be talking about swinging doors today. And they need to swing in the direction of egress or swing out of the room or space when serving an area of 50 or more people, regardless of regardless of occupancy type, and Group H, high hazard occupancy, regardless of the occupant load. Next, we'll learn how to use the calculator. This is the new ASSA ABLOY Egress Calculator website, and I want to show you how to navigate the first couple of screens. On the top left, there is a menu. You can link to ASSA ABLOY Academy for all of our online courses and virtual instructor-led training, as well as find any training in your area once we go back to traveling. Also, you can download the Excel versions of the Egress Calculator here. They will still be kept up to date in place for your use. Door Security Solutions, ASSA ABLOY Door Security Solutions has all kinds of products if you're interested. And then our ASSA ABLOY Architectural Services, if you are an architect or contractor in need of a specification, you can click this link and it will show you who the team is, who to contact, and our code resource guide can be downloaded here. The Overview tab lets you know that this application is a tool in assisting not just architects and consultants, but ASSA ABLOY employees, contractors, anybody in the door openings industry that has anything to do with checking occupant load, egress width, door swing, selecting hardware, any of those kinds of things. It will help you determine the occupancy use and type of a building so that you can properly select the appropriate hardware. It will help you calculate the occupant load for a room or space and for each occupancy type based on the formulas in IBC. It will help you calculate the minimum clear opening width of doors from a room or space. You can determine the swing direction of doors from a room or space and determining the minimum number of exits and exit access doors from a room or space. This tool additionally has notes that will help you select the appropriate hardware. It is not meant to be in place of having your own copy of the IBC. You still need to have a copy of the code book to look up the references and to apply things like travel distance to exits, separation of exits, common path of travel, and things like that. This tool does not help you with those items, but you can always buy a copy of the IBC from iccsafe.org, whether it's in PDF or hard copy format. This is next the Occupancy Use Type tab. You click on it, and if you need to review your occupancy type, we've already gone through and talked about what is a Group A assembly. But this gives you a reminder of what an assembly occupancy is. It also goes through and lists more in-depth examples for each type. You can scroll down and remind yourself what a Group B business occupancy is. Educational, factory. Once you have determined the occupancy type, then you will be able to go in and select the appropriate calculator. A couple more definitions that we need before we can start using the calculator. There are two different types of floor area. The gross floor area by definition is the floor area within the inside perimeter of the exterior walls of the building that's under consideration, exclusive of vent shafts and courts, without deducting for corridors, stairways, ramps, closets, the thickness of the interior walls, columns, or other features. and the net floor area, which is the actual occupied area, not including unoccupied accessory areas such as corridors, stairways, ramps, toilet rooms, mechanical rooms, and closets. In Chapter 10 of the IBC, 1004 deals with the occupant load, and the design occupant load is determined by this section. It is the cumulative occupant loads for intervening rooms and spaces, and areas that don't have fixed seating are based on table 1004.1.2, which is what the egress calculator is based on also. And there are exceptions where approved by the AHJ, the authority having jurisdiction, the actual occupant load shall be permitted. For example, classrooms in educational occupancies for health safety reasons are required to have a larger per square foot per student so that they don't pass germs amongst the students, and it gives them plenty of space to be able to do whatever they're working on. But if you were to calculate the occupant load of that size room, you would come up with a much higher number of students than what is actually going to be in the classroom. And so, for example, if 35 is the maximum number of students in the classroom, but the calculated occupant load is over 50, the AHJ could allow a sign to be posted, maximum occupant load of 35, and you would only need one exit access door from that room, and the door could swing in and would not need an exit device. The drop-down menus in the egress calculator are the same as the ones on table 1004.1.2 in the International Building Code. They are just arranged by occupancy type, but that does not mean you can only use that occupancy type for that function of space. For example, the educational occupancy calculator is typically educational as K through 12, including nursery schools and some daycare. But a classroom that is found in another occupancy, let's say a training room or something like that, is not under the assembly occupancy tab. You won't find training room in here because there's nothing listed on this table about training rooms. But because it's a educational classroom area, you would use that calculator to get the appropriate number of people. And then you can go from there. If the number of people is over 50, then it does become Group A assembly and would become a mixed occupancy with the business or the residential or whatever else it's being mixed with. But if we look at the assembly occupancy calculator, you see assembly here. If you have fixed seats, you can go to the fixed seats and just put in the number of fixed seats. If you have concentrated assembly, you would use this one. And this, the values in the calculator here will be the same as concentrated use chairs only, which is 7 net square foot per person. If you go with standing space, then you would use this one, and that corresponds to the standing space, the 5 net square foot per person. If you go to the unconcentrated use, that's the same as here, unconcentrated tables and chairs, 15 net square foot per person. Even though you don't see that, this calculator is based on this table in the IBC. If you ever have any question as to what these values are, you can always go to table 1004 in the IBC and find them. Library, reading rooms, and stack areas. Because library can be assembly, I put it under this tab. So library reading rooms are net, which matches up with library reading rooms net. It's 50 net per person, net square feet per person. The stack area, library stack areas, could also be assembly, and that's 100 gross. For this one, I did put this under the educational occupancy as well, because you do have libraries within educational quite frequently. So for ease of use, I did try to combine some of these into the more common calculator. But if we go to mercantile, for example, mercantile gives us area on other floors. Mercantile, that would be the 60 gross square foot per person. Our other option would be the storage, stock areas and shipping areas, and that would be following this storage stock, 300 gross per person. So if I were to type in 3,000 square feet and calculate, my occupant load is 10, which it should be, because 3,000 divided by 100, 3,000 divided by 300 gives us the 10. And that's exactly how this calculator works. It is based on the area in the table 1004.1.2 for calculating occupant loads. We talked about mixed use a little bit earlier. Some areas that could be red flags in business occupancies or other types of occupancies that could be considered Group A assembly, which would have the more restrictive hardware requirements. You would use the unconcentrated assembly calculator if you have a room that has tables and chairs, a conference room, lounges, balconies, rooftop patios, and dining areas. And then if at 50 net square foot per person, if the occupant load is over 50, then it is assembly, and you would treat the hardware based on assembly occupancy. For concentrated assembly, like a multi-purpose room, a meeting room, a ballroom, or a banquet room, those could be just chairs only, and therefore you would use the concentrated assembly to determine your occupant load for those types of spaces. Those that you would use the educational calculator, which is 20 net square foot per person, would be for classrooms, training rooms, and lecture rooms in other types of occupancies, like a business occupancy, or maybe you've got a hospital that has a training room or a lecture room there. And then the educational calculator for training shops, labs, and other similar vocational use may be within another occupancy type. This is a hotel, and a hotel in and of itself is a residential occupancy, R1. You have your guest rooms. This is the first floor. But I want to look for any red flag areas. And in Bluebeam, if there's no dimensions, these dimensions don't really help me tell how big this fitness room is, the fitness center. And if I want to verify this in my Egress calculator, first I have to calibrate. If you go to Tools, and then you come down to Measure, you can calibrate the scale. I know this door is 3 feet wide, so if I click there and click there, then I can input that it's 3 foot, and then hit Apply Scale. And now I can go back to the Tools and Measure and get the area. There's 2 ways I can get the area. I can just click on the corner and drag it out to the other corner and let go, and that tells me 678.55, which a fitness center, if we use the drop down, is an exercise room. And without sprinkler system, I can put in my room square footage. I'm just going to round it up to 679. Hit Add. And I can see my calculated occupant load is 14, which I know based on experience that with 14 people, this door can swing in, and I only need 1 exit access door, which is what this room has. So this is not an assembly occupancy. I'm less than 50, I'm sorry. And I can hit calculate, and it tells me that I need 2 exit access doors, 32 inches minimum clear. The door can swing in or out. However, if you scroll down to the assembly special notes and look down here, table 1015.1 says that 1 exit is permitted when an occupant load is 49 or less. We have less than 49 people. This fitness center can have the 1 exit access door, and we are good. But now I want to check to see if there's any other possible red flags. And as I scroll down, here's a meeting room. Now this meeting room could very easily be assembly. It's got 2 exit access doors, which leads me to believe that it is big enough. We can reset our calculator here, and I've already got my calibration, so I don't have to recalibrate again. I just go to measure and area. And a meeting room can be considered either concentrated assembly or less concentrated assembly. And since a meeting room could be used for either purpose, we have to go concentrated, because there could be times where somebody rents this meeting room and all they've got is chairs, and they have a lot more people than if they set it up more like tables and chairs. We have to go with concentrated chairs only instead of unconcentrated to figure out whether this is assembly. Without sprinkler, it's still checked. I've got my square footage as 868 and hit add. And sure enough, I've got 124 people, which if I did this using unconcentrated and the same square footage, 868, I'm just going to hit add. That's 58. It's still going to be over the amount for assembly. Either way, let's hit clear. Well, we have to calculate, but let's hit reset because I don't want to have both of them in there. Let's just do for the concentrated. Go back here, 868, hit add, and then calculate, which in fact tells me with 124 people, I do need 2 exit access doors, which I have. They need to be 32 inches minimum clear. These are 3-foot doors with 33 inches minimum clear, so I've got that. The doors do need to swing out. They do. Exit devices are required, and then any of my special hardware notes are down here. So if I'm writing the specification or detailing this, or if there is a hardware specification written, and this is anything other than an exit device, now if it's push-pull, let's say this door doesn't need to lock, push-pull would be acceptable if it's a non-fire rated door. But if it's a fire rated door, this door needs to latch, and an exit device here and here would be appropriate. But we follow our path of egress. That means we also need exit devices on this because we've got a mixed occupancy, residential mixed in with assembly. We also have this breakfast area, which looks like it's large enough to be considered assembly. So between these two, we definitely have mixed occupancy. This would need an exit device. These doors would need an exit device if they latch. This one for sure because it's an exterior door. And then to keep continuity, these doors on this end as well, even though they don't technically need it because our second exit is this door, this one needs an exit device. These sliding doors may or may not be factored into our egress capacity, but we have enough egress capacity with this one door and this corridor down here. But I would do the same thing for hardware and put exit devices here for continuity, symmetry, and the like. The second way to get the area using Bluebeam, first I'm going to calibrate because this is a different set of plans. So under Tools, go to Measure and then Calibrate. I know this is a 6-foot pair, so I'm going to put that in here, apply scale, and now this fitness center is not just a rectangle. So you go to Tools, Measure, and Area, and instead of clicking and dragging, now you click on this corner, and then here, click again, here. We're getting the outline of this really crazy space, and just click it once at each of these locations. There, and then double click on the last one to set it. And that gives you the total square footage for the fitness center, and then you can put it into the egress calculator from there. As I mentioned earlier, the egress width is measured from the face of the door to the face of the stop when the door is open 90 degrees. And you don't have to take the hardware into consideration unless it projects more than 4 inches off the face of the door. And In order to determine how much egress width that we need, our other egress components, which would include doors, will be sized as follows. For a non-sprinklered building, 0.2 inches per person. If it is a sprinklered building, it's 0.15 inches per person. That's why we have the radio button on the egress calculator, because it will affect your overall width that you need for your doors. There is an exception in Group H, high hazard, and also in I2, which is your healthcare, hospitals, and nursing homes. Those are factored in at 0.2 inches per person because those buildings are already sprinklered and we're dealing with either high hazard or wider doors that staff will be evacuating. This set of doors right here, even though it's 4 doors, 1 pair and 2 single, that's considered 1 exit, even though there's multiple leaves. But because this is a very large space, this is a school, our occupant load is such that we need this many doors for exit purposes. The way that you can calculate that, a 36-inch wide door by itself, subtract the 3 inches to get the clear width. We have 33 inches clear. Divide that by 0.2 inches per person for a non-sprinklered building, and you come up with an exit capacity for a single 3-foot leaf of 165 people. Your pair of doors, you're going to subtract 6 inches. Even if you have a hardware mullion in the center, whether it's removable or fixed, this will take that into consideration. And that gives us 66 inches clear. 66 divided by 0.2 inches per person is 330 people. So all totaled, with these 4 door leaves, we have an exit capacity of 660 people. And this is, as I mentioned, a large school. This is just one of the many exits that are required, and we need that much for egress width. Now let's take a look at some examples and exercises. The first one is going to be a 2-story office building, which is Group B business. There is no sprinkler system. It's new construction. We don't have any life safety plans. The hardware specification is due in the morning and it's too late at night to call the architect. Just want to verify this training room and doors A and B that are 3 foot by 7 foot. Make sure that if we need exit devices on these doors, then this door would have to change swing. And rather than assume, we're going to use the egress calculator to just double check real quick. In this exercise, we have an office building, Group B business, with no sprinkler system. And the red flag area that we're looking at is this training area. Now, you won't find anything under the business occupancy tab for training areas, so you have to determine what is a training room similar to in our table 1004 from the IBC. And as I had mentioned before, Educational Occupancy Calculator has classroom areas, and a classroom area is just like a training room. And so we have to use this to determine, do we have 50 or more people? Once we have 50 or more people in this training room, then we do have to consider it Group A assembly. These doors would need to swing out. We would need exit devices on these doors, as well as any other path of egress in this office building that intermingles with that same path of egress. Because a classroom is used a little bit differently than other areas of assembly, it's 20 square foot per person. I will go over here and enter 26 feet for my one dimension. My other one is 33. I hit add and calculate. My occupant load is 43 people, which is significantly under the 50, and therefore I should be fine with exactly how the architect has this drawn. I need 2 exit access doors, 32 inches minimum clear. These are 3 foot wide doors. The doors can swing either in or out. This one swings out, this one swings in. They're both completely fine, and exit devices are not required. If I scroll down and I take a look at the special notes based on educational occupancies, Table 1015.1 tells us that one exit is permitted when I have an occupant load of 49 or less. And that is indeed the case. So I can have one exit access door from this space. I don't even need the two. I am in compliance. I can go forth with this project without exit devices on these doors, knowing that the quantity of exits, exit access, the widths, swing direction, everything is fine. An additional option, if I want to save this information, I can put the room name, drop down and select the date, put in the project name, and then I can save this information, download it into a PDF, and keep this in the project file for future reference. So if there's ever any question, why didn't you put exit devices on these doors? I can pull this up and say, that room was under 50 people, it's not assembly. I can have one exit and I did not need exit devices. You've got your justification for that in your file. The next one is also an office building. The doors are 3 foot and it's a non-sprinklered building. We have two areas that we want to check to see if they're assembly or not. With this exercise, there are two red flag areas in this business occupancy. First, we've got to check the conference room and then the multipurpose room. Just from it looks like to me the conference room is small enough that it would not be considered assembly, and therefore this one door should be enough, but let's confirm that. With the assembly occupancy calculator, a conference room is considered unconcentrated use with tables and chairs. And then this building does not have a sprinkler system, so we will leave that checked. And I've got 19 feet by, I'm going to round the 26 up to 27, hit add and calculate, and 35 is less than 50. And because we have one exit permitted when an occupant load is 49 or less, this conference room is fine. I'm going to hit reset. And now the multi-purpose room, it could be concentrated assembly with chairs only, not fixed, or it could be unconcentrated with tables and chairs. Because it's a multi-purpose room, we have to factor it based on concentrated use, worst case scenario. And you can see that there are two exit access doors, but the doors swing in. If this is large enough to have 50 people, these doors will need to swing out, and it will make it a mixed use occupancy between assembly and business, and our egress components will need to be updated accordingly. Let's input for concentrated use. Again, the reason we're doing that, a multi-purpose room, this is a big screen here. They could just have a bunch of chairs lined up in rows to look at some kind of video or something like that. And therefore, we have to use concentrated, put in our room size. It's 42 feet by 20. And you can go 20.1 or 20 point whatever, but let's just round up, hit add, and we have over 100 people. Calculate. I do need two exit doors, exit access doors, which I have. They need to be 32 inches minimum clear. These are 3 foot wide doors, so I have 33 inches clear. I'm compliant so far, except that these doors do need to swing out and they do require exit devices. I would have to inform the architect, can you please change the swing direction of these two doors? And then I'm going to have to put exit devices, not just here, but any path of egress out of the building. This is a one-story building. The problem now exists when you swing this door out. If this is an egress corridor, now we have to pay attention to encroachment, which means that during this swing, this door cannot cut down more than half the required width of this corridor. It can bring up other issues, and this door can swing. You can't really quite see it, but there is another door right here. We may need to have the architect pocket or recess these doors instead of having them swing onto the corridor. They can swing out, but up against a wall or something like that. And another office building with no sprinkler system. The next exercise asks for this business area, which is in gross square footage, do we have the appropriate number of exits? Do they swing in the correct direction, and are exit devices required? We have door A, which swings in, door B swings out, and door C swings out. We go to our business occupancy calculator because the open workstation area, the conference room, and these offices, this is business use space. This conference room is way too small. It's not assembly. There is no assembly in this space. So let's take a look with business areas because it's not accessory storage areas. We want business areas. Our scenario is without sprinkler system, and we know how many square feet. I input 6,000, I hit add, I hit calculate. I have 60 occupants, which means that the doors do need to swing out. But because this is a business occupancy, you can see that exit devices, panic and fire exit hardware is not required. This isn't an electrical room, this is regular business use. This open workstation area is going to be filled with cubicles and freestanding office space, office area. And the people, even though there's 60, the people will reach the exits at different times. Completely different scenario than if this were a big wide open multi-purpose room or ballroom or banquet room or something where you had a large number of people assembling together. Because this is business use, exit devices are not required, but once you get to 60, actually 50 or more, then the doors do need to swing out. I need a minimum number of 2 exit access doors, so B and C comply with that. Door A can swing in. It's not a exit. There wouldn't be a lighted exit sign above here, but these 2 doors meet your requirements for means of egress, and you don't need exit devices on any of those 3 doors. And just because the code does not require exit devices doesn't mean that you can't use them. They may be the best solution for hardware depending on the type of traffic and how often that they're used. Next one is one that we see quite often. We have a hotel that has meeting rooms, and the meeting rooms have operable partitions in between, so they can open them up and use 2 rooms together or all 3 rooms together. It is a fully sprinklered building. The single doors are 3 foot, the pairs of doors are 6 foot wide. In this exercise, we have a hotel, which is a group R1 residential occupancy, but these are some meeting rooms, which is pretty common. You'll find them typically on the first floor of a hotel if they have meeting space. And we see the operable partition separating each one of these meeting rooms. The way that we need to calculate this to double check, do we need exit devices on these doors, is each of these meeting rooms individually, and then what is the total when all of these operable partitions are open and they use it as one overall large space. A meeting room, if it's going to be assembly, if it's large enough to be assembly, would have to be calculated on concentrated use, chairs only, not fixed, instead of unconcentrated use. Because meeting rooms can be used in either configuration. You could have just all chairs, or you could have a combination of tables and chairs. So let's go with concentrated use. It is a full sprinkler system, so we need to check that. And our first room length is 26 by 42. So 26 by 42, and I hit add. Then I can add another function of space, which would be the second one. Before I do, I want to take a look. I've got 156 people just in this space alone. And I could hit calculate and see that I do need a minimum of 2 exits from this space, exit access doors, which I have, 1 here and 1 here. My minimum is 32 inches, so I do not, with this occupant load, go over the minimum clear. This pair of doors is bigger than what we need, but I'm sure that it's symmetrical, and it's probably needed once you get to the full space. because of that, I know that these other two are going to be very similar. This isn't that much larger. I may have another 20 people or so, which will still be within the 2 exit access doors and the same parameters here. Let's go ahead and now add our next function of space. We've still got concentrated use. The next one is 32 by 42, and hit add. And then this, when I hit calculate, will total these together. We did have an extra almost 40 more people here. And if you wanted to, you could calculate it now and see that if both of these were open, this open, and both of these used, and this were closed, I would still need 2 exits or exit access doors. I still need 32 inches per exit access, but a total of 52 inches, 52.2 total between all of my exit access, which I do have. But let's add in the third one. It's still concentrated use. Our third one is 27 by 42. Hit add, calculate, and that one is 162. So each one of these rooms is very close to the same size, but now my total is 510. I need a minimum of 3. When all of these partitions are open and I'm using it as one large space, I need a minimum of 3 exit access doors, which I've got 1, 2, 3, 4, 5, and 6. Each one needs 2. We have it. The total needs 3. We have it. The minimum clear per exit is 32 inches, and the total clear egress capacity width 76.5. My minimum main entrance, and since I don't really have a main entrance, that's why each of those is a pair. We could do that with a single 4-foot leaf, but this architect chose to go with pairs, which is fine. It exceeds what we need. And exit devices are required in every scenario because each one of these is over 50 people. And our assembly special notes, we can see if we have certain types of hardware and what my IBC references are so that I could go look them up. I have not seen any questions yet, but if you have a question, feel free to type it in. In the meantime, this is where you can access the Egress Calculator for yourself. It is a free tool for anybody to use, so if you've got other colleagues and you want to share it, feel free to give them the link. It's egresscalc.asaabloy.com. You can use it on your desktop, tablet, or smartphone. So if you happen to be at a job site, you can pull it up on your phone and do a quick calculation. It's based on the International Building Code. You can use it to calculate the occupant load, the egress width, the quantity of exits, the swing direction of exit doors, all with quick references to code compliant hardware listed at the bottom. You can download and save the input and output data in PDF form, and when you save it with the project name and the date, it also saves your code references for your hardware so that, for example, if you did use delayed egress, it gives you the reference of where you found that you could use that. It's free to use with single sign-on for ASSA ABLOY employees, or connect if you are a distributor partner, customer of ASSA ABLOY. If you're an architect or a contractor or other, then it's a guest login. Very minimal information that you input. The cookies in there will keep you signed in for about 30 days. If you use it once a week or once every day, then it should keep you logged in every time that you come back to it. If you are not using it that frequently, then you may have to put in the information each time. If you have any questions down the road, or if you have any comments once you start using the calculator, please feel free to email me at catherine.flower@asaabloy.com. And if you have other coworkers or customers or anybody that could use this tool, we have these classes once a month. They're on ASSA ABLOY Academy under the virtual instructor-led training, and just have them look for the same title, calculating occupant loads and egress width. So unless we have any questions, I want to thank you for your time this afternoon. Thank you for your attendance, and be looking for that email with the thank you and potentially using that for continuing education credit. Hope you have a wonderful afternoon.